It is really difficult to count the wonders of our wonderful nature or to enjoy them all together. But still, we try to overcome those difficult things and enjoy the beauty of nature. Sometimes we succeed and sometimes we fail. A natural wonder that has so far not been 100% successful is that the inability to fully harness the electrical energy generated by lightning in the sky. We know lightning in the sky is one of nature's most powerful displays, with a single bolt carrying an immense amount of energy. But can this energy be harnessed and used to power our homes? Let's explore the fascinating possibilities and scientific realities of capturing and utilizing lightning's electricity. What is lightning? Lightning is a natural, extremely powerful electrical discharge that occurs in the atmosphere. It typically appears as a bright flash of light in the sky, often accompanied by a loud sound known as thunder. Lightning is one of nature's most dramatic known phenomena, resulting from the build-up and discharge of high volume of electrical energy between clouds, the air, and the ground. Why does lightning flash in the sky? Lightning flashes in the limitless sky due to the rapid movement of electrical charges within storm clouds. When the electrical potential between a cloud and the ground, or between two clouds, becomes great enough, it overcomes the insulating properties of the air. This results in a sudden release of energy in the form of a lightning bolt, creating a bright flash which we can see from the ground of Earth. Why do we hear the sound of thunder after lightning strikes? Thunder is the sound produced by the rapid expansion and contraction of air heated by the lightning bolt. When lightning strikes, it heats the surrounding air to temperatures around 30,000 Kelvin or 54,000 degrees Fahrenheit. This rapid heating causes the air to expand explosively, creating a shockwave that we hear as thunder. The sound of thunder travels slower than light, which is why we see the lightning before we hear the thunder. Note that the speed of light is 299,792,458 meters per second, whereas the speed of sound is 343 meters per second. What is the cause of lightning? Lightning is caused by the separation of positive and negative charges within a storm cloud. This separation is typically due to the collision of ice particles within the cloud, which transfers electrons and creates regions of opposite charge. When the electrical potential between these regions becomes large enough, a lightning discharge occurs to neutralize the imbalance. Types of lightning. Number 1, cloud-to-ground lightning. This type occurs between a cloud and the ground. Number 2, intra-cloud lightning. This type occurs within a single cloud. Number 3, cloud-to-cloud lightning. This type occurs between two separate clouds. Number 4, cloud-to-air lightning. This type occurs between a cloud and the surrounding air. Number 5, bolt from the blue, a type of cloud-to-ground lightning that originates in the upper regions of a cloud but strikes far away from the cloud base. What is the rarest type of lightning? Ball lightning is considered one of the rarest types of lightning. It appears as a glowing spherical object that can move slowly across the ground or float in the air. Ball lightning is poorly understood, and its exact causes and nature remain subjects of scientific research. How does lightning form in clouds? Lightning forms in clouds through the process of charge separation. Within a storm cloud, various particles such as ice crystals, water droplets, and hailstones collide and interact. These collisions cause electrons to be stripped from some particles and transferred to others, creating regions of positive and negative charge. The strong electric field generated by these charges eventually leads to a discharge, resulting in lightning. How many electrons are in a typical lightning bolt? A typical lightning bolt can transfer about 10 to the power 20 electrons, namely 100 quintillion electrons. This massive flow of electrons is what constitutes the electric current in the lightning strike. How much electricity does one lightning strike have? A single lightning strike can carry an electric current of about 30,000 amperes and a voltage of several hundred million volts. The total energy released by a typical lightning bolt is approximately 1 billion joules, equivalent to the energy released by detonating about 250 kilograms or 550 pounds of TNT. What happens to electrons when lightning strikes? When lightning strikes, electrons move rapidly through the air, creating an ionized path known as a plasma channel. This channel allows the electrical charge to travel from the cloud to the ground or between clouds, neutralizing the charge separation that caused the lightning. The intense energy of the moving electrons also generates light, heat, and sound. How fast do electrons move in lightning? The electrons in a lightning bolt move at a significant fraction of the speed of light, though not as fast as light itself. The speed of the electric discharge in a lightning bolt is around 1/3 the speed of light, or approximately 100,000 kilometers per second, which is about 62,000 miles per second. However, the individual electrons themselves move much more slowly due to collisions with air molecules. Already we have known a typical lightning bolt can carry around 1 billion joules or 277 kilowatt hours of energy. To put this in perspective, the average home in the United States uses about 30 to 35 kilowatt hours of electricity per day. Therefore, a single lightning bolt has the potential to power a typical home for roughly 9 to 10 days. Now the question is it possible to store and use the energy from a lightning bolt? Theoretically, it is possible to capture and store the energy from a lightning bolt. However, several significant challenges make this difficult in practice. Challenge number one, high voltage and current lightning bolts have extremely high voltage, approximately up to 1 billion volts, and current up to 30,000 amperes. Capturing this safely without any damage requires a proper technology that can withstand and manage such immense power. Challenge number two, unpredictability. Lightning strikes are unpredictable in location and timing, making it challenging to rely on them as a consistent energy source. Storage. Storing the energy from a lightning strike requires big and different capacitors or batteries capable of handling sudden, massive surges of electricity. A question arises accordingly, and that is, can current technology capture the electricity generated by a lightning strike? While there have been experimental attempts to capture and store lightning energy, current technology is not yet capable of doing so efficiently or safely on a large scale. The infrastructure needed to capture lightning's energy, such as large conductors and high-capacity storage devices, poses significant engineering and economic challenges. In theory, if we could develop the technology to safely and efficiently capture, store, and convert the energy from lightning strikes, it could become a renewable energy source. However, due to the sporadic nature of lightning and the immense infrastructure required, it remains more of a scientific curiosity than a practical solution at this time. After all these speculations, now we would like to know that how much electrical energy is stored in a lightning cloud. A typical thunderstorm cloud can store a substantial amount of electrical energy, potentially equivalent to multiple lightning bolts. However, releasing and capturing this energy in a controlled manner remains beyond our current technological capabilities. Currently, using lightning as a reliable source of electricity for domestic or industrial use is not feasible. The challenges of capturing, storing, and managing such high-energy events are significant. In whatever way, continued research into advanced materials, energy storage, and lightning behavior may eventually make this a viable option. There have been several attempts and experiments to capture and store the energy from lightning bolts. Scientists and engineers have experimented with various methods, including the use of large metal rods and conductive materials to channel lightning strikes into storage devices. One notable attempt was conducted by scientists at the Florida Institute of Technology, who studied the feasibility of capturing lightning energy. Anyway, these experiments have highlighted the immense challenges and have yet to produce a practical and scalable method for harnessing lightning energy. In conclusion, it can be said that lightning holds an awe-inspiring amount of energy, but harnessing it for practical use presents many challenges. While a single bolt of lightning could theoretically power a home for several days, the unpredictability and intensity of lightning make it a difficult energy source to capture with current technology. Future advancements may unlock the potential of this natural phenomenon, transforming it from a scientific curiosity into a practical energy solution. If you like the video, then let me know, and I will come up with another video on it. And that is, why do people or animals die if lightning strikes people or animals? Curious about the future of renewable energy and cutting-edge science? Subscribe to our channel for more intriguing insights and join the conversation in the comments below. Thanks to everyone. Question for viewers. Number 1, what is the speed of light? Number 2, what is the speed of sound? Number 3, what is the charge of an electron?